Welcome to this explainer, everyone. To all the first-year students tuning in, I am absolutely thrilled to have you here. Think of me as your industry mentor, right? And today, we are going to lay down the absolute groundwork for your future. You're stepping into a B.Tech in Petrochemical Technology. Let me tell you, this is a field that isn't just incredibly lucrative, it is literally shaping the future of global energy and sustainable materials. You've worked so hard to get here. So over the next few minutes, I'm going to give you the insider's playbook on how to not just survive this degree, but how to actually thrive, innovate, and build an extraordinary career. All right, let's get into it.
Okay, let's dive into this. If you're sitting there right now feeling a little bit of anxiety mixed in with your excitement, you really need to know about the imposter phenomenon. Dr. Lisa Bullard perfectly describes this transition from high school to engineering. She says it's like stepping out of a familiar, safe, one-person kayak right onto a remote, intimidating island with steep cliffs and natives speaking a language you just don't understand. If you're looking around at your classmates and thinking, wow, everyone else gets this, I somehow just fooled them into letting me in, I want you to hit pause. Seriously. Almost everyone in your class is playing that exact same self-doubt tape in their heads. It is completely normal to feel overwhelmed by the transition right now. You belong here, you absolutely have what it takes, and we're going to scale those cliffs together.
So here's our map for today's explainer. We've just welcomed you to the island. Next, we're going to map out the engineering branches, explore your academic blueprint, take a look at the green tech horizon, break down global salaries and careers, and then we'll wrap up with my personal mentor survival guide.
Moving right along to Section 2, mapping the engineering branches and really finding your place in all of this.
And this brilliantly illustrates the difference between two deeply connected yet distinct worlds. Think of petroleum engineering as the upstream sector. These are the folks out there finding the reservoirs, modeling the geology, and actually drilling the wells to extract the crude oil. But, that crude oil isn't very useful on its own. And that is exactly where you come in. Petrochemical Technology is the downstream sector. You are the ones taking that raw material and using advanced chemical synthesis to refine it into fuel, advanced polymers, plastics, and all the specialty chemicals that make modern life possible. Both sides are absolutely vital to global energy and manufacturing.
All right, on to Section 3, your academic blueprint, navigating the syllabus.
Now, your degree is highly structured and it builds in complexity year over year. In year 2, you're going to lay the groundwork with foundational transport and thermal systems. Then, year 3 is where things really heat up. Literally, you'll dive into primary and advanced downstream operations, focusing heavily on how a refinery actually works day to day. Finally, year 4 shifts toward the bigger picture. We're talking process optimization, the actual economics of running a massive plant, and of course, executing your capstone research project.
Take a look at Semester 3 here, straight from the NN University syllabus. You'll encounter foundational courses like Chemical Engineering Thermodynamics and Fluid Mechanics. Now this right here, this is where your real engineering mindset begins. You're moving way past the basic physics and chemistry of your freshman year, and you're starting to learn the core languages of a process engineer. Then, pushing into semesters 4 and 5, subjects like mass transfer, which is essentially the science of how chemicals separate and combine, will really challenge you. These courses are notoriously demanding. But listen, I need you to remember this. These aren't just academic hurdles you have to jump over to graduate. These subjects form the absolute foundation of everything you will do in your career. Whether you're scaling up a traditional refinery or designing a brand new sustainable chemical plant, you are going to use these principles continuously.
Let's shift gears to Section 4, the green tech horizon, engineering the sustainable future.
Here is the reality. Yes, the world absolutely needs traditional fossil fuels right now. And petrochemical engineers are exactly the people who are building the green transition. Just look at that number, 97%. Companies like Applied Bioplastics are using plant-based polymers to replace traditional petrochemical content in manufacturing. By doing that, they can actually reduce the carbon dioxide emissions of plastic manufacturing by up to 97%. This isn't just some textbook theory. This is real, scalable technology happening right now. So the crucial point is that your skills transfer perfectly into this green tech space. The process basically involves sourcing agricultural plant matter and then producing plant-based polymers using the exact same traditional equipment that plastics manufacturers already have in place. And how do we change the world without putting traditional manufacturers out of business? Well, through licensing. By licensing these sustainable technologies to global giants, your petrochemical expertise becomes the very engine driving massive global decarbonization. You are literally engineering the sustainable future.
Which brings us to Section 5, global salaries and careers, the reward for hard work.
Let's talk about the payoff.
The incredibly lucrative salary scales waiting for you in India look a bit like this. For freshers, you're looking at a really solid 4 to 8 lakhs per annum. But get this, with just a few years of experience, mid-level engineers quickly jump to the 10 to 20 LPA range. And for senior professionals, you are looking at 25 to over 50 lakhs per annum, which, I promise you, will make all those intense late-night study sessions completely worth it. In fact, students with strong academic and project-based training are already securing top domestic packages like 25 LPA right out of the gate at major public and private sector firms.
And hey, if you want to travel, the overseas opportunities are phenomenal. We're talking average salaries of $150,000 in the USA, $160,000 in Norway, and $120,000 in the UAE. Plus, many of these international and offshore roles offer rotational schedules. That means you might work 15 days on and then have 15 complete days off to travel or just go home. Your degree gives you the ultimate adaptability to work literally anywhere in the world.
So, who is eagerly looking to hire you? Honestly, you have incredible corporate, research, and industrial environments just waiting for you. You've got the massive stability of the public sector undertakings, places like ONGC and IOCL. You have global giants like Shell and ExxonMobil. And of course, you have the highly innovative specialty polymer and green tech spaces like Applied Bioplastics and Lancis. The demand is absolutely there, you just have to rise to meet it.
Finally, let's hit Section 6, the Mentor's Survival Guide, Rules of the Jungle.
Okay, here are my rapid-fire survival rules for you. Number 1, develop a stubborn work ethic. Brilliant high school students often stumble here because, well, you just can't study the night before anymore. 2, work in groups but make absolutely sure you can master the problems independently when exam time comes. 3, get organized and absolutely avoid procrastination. These problem sets take days, not hours. 4, embrace your peers. They are your community and your future network. And 5, there is zero shame in asking for help when you're lost. Go to the TA, go to the professor. Whatever you do, don't fall behind.
Now, what's really interesting about this slide is this specific advice from a former student. They said, do not get into the habit of plugging and chugging. Look, in high school, you memorized formulas. In petrochemical technology, you have to completely retrain your brain to think like an engineer. You need to understand the physical reality of the process, analyze it, and logically figure out the solution. Memorization won't save you here. Critical thinking will.
Ultimately, I want you to study this field for the right reasons. Choose this major because you genuinely want to learn, to grow, and to pioneer. Whether you spend your career refining traditional crude oil to meet the demands of today, or synthesizing cutting-edge green biopolymers to save the world of tomorrow, your absolute greatest asset in this shifting economic landscape is your adaptability and your commitment to continuous learning. So, I'll leave you with this provocative thought. You are about to acquire one of the most powerful and versatile toolkits in the modern industrial world. The global demand is there. The technology is evolving rapidly. So I ask you, how will you use your engineering toolkit to shape the future of global energy? Confidently take that step onto the island, embrace the challenge, and become the innovator this world desperately needs. Thank you so much for joining me in this explainer, and I wish you the absolute best in the incredible journey ahead.